Hey guys, welcome back to the YouTube video. Today we're going to talk about the part 2 version of Earth. In the last video we did talk about Earth, but in this one we're going to talk more about it. So this is why we're having a part 2 version, because I didn't want to make the last video too long. So today about Earth we're going to talk about how the Earth formed, how the Moon formed, and how the life has formed. Now, first, as you probably guessed, we're going to talk about how the Earth was formed. So, the Earth formed over 4.6 billion years ago out of the mixture of dust and gas around the young sun. It grew larger thanks to the countless collisions between dust particles, asteroids, and other growing planets, including the last giant impact that threw enough rocks, gas, and dust into space to form the moon. So, scientists now think the Earth's story began around 4.6 billion years ago in a disc-shaped cloud of dust and gas rotating around the early sun, made up of material left behind after the sun's formation. Excuse me guys, let me check something. Yes, okay, everything's going. Okay, so about 4.6 billion years ago, the Earth story has began, roughly. Most of us thought it was 5 billion years ago, but now scientists believe it's 4.6 billion years ago. So 400 million years quicker than expected. Shorter, I mean. So, within the disk, gas and dust particles of different sizes orbited the sun at slightly different speeds, allowing them to bump into each other and stick together. Eventually, they grew from tiny dust grains into boulders, then into larger planetesimals that ranged from miles to hundreds of miles in diameter. So, as the particles, like dust and gases, all came together, they all formed up into one bigger object over the years since the birth of our solar system was formed. So, because these planetesimals were larger than the boulders, they had strong enough gravity to pull neighboring planetesimals out of orbit and absorb them through collisions, enabling some planetesimals to grow bigger and bigger until they reached thousands of miles in diameter, about the size of the Moon and Mars. So this is the artwork of as all the pieces of rocks and other materials, gas, all colliding into one big gigantic rock, which is our planet. Back then it was just a like Venus, even hotter actually than Venus. You can tell it's all made out of lavas and molten rocks. So we're going to get more into that later, because now, guys, we're going to talk about the moon. So after the moon, we're going to talk about how the water formed and how the life formed and that. So don't worry. So now we're going to talk about how did the moon form. So several different formations theories for the moon have been proposed by scientists. The story that is best supported by all the available data, however, is that the moon formed during a giant impact between the proto-Earth and another protoplanetary planetary roughly the size of Mars, sometimes called Theia. So, guys, another planet has actually collided with Earth. Also, back then, Proto-Earth. Proto-Earth is when the Earth was like this, for example, when it was all just orange and covered in big lavas and molten rocks. Back then, it was just called Proto-Earth. And another planet called Theia has apparently collided with Earth, and apparently this is what caused Moon to form. So, in this theory, the Moon formed from the impact debris, a mixture of molten rock and hot gas flung out into space by the impact, potentially forming a disk of material known as lunar synestia. So, this is the artwork creation of what it might have happened when the time the moon was formed, that is orbiting around our planet right now. The piece of rock that we see in the sky at night or sometimes during the day. Um, as you can see, Earth at the beginning with another planet material, Theia object, colliding with Earth, creating a donut shape impact, and this is apparently how the moon was officially formed. But we don't actually know, guys, exactly how the moon was formed millions of years ago. So when did the moon form? Well, I did say millions of years ago, but exactly when? Scientists believe the moon formed during a giant impact about 60 to 175 million years after the solar system was born. To arrive at this estimate, they can use rocks from Earth. So the rocks that we find on Earth, the scientists can use that to find out exactly when exactly the moon was formed. Well, that's interesting. So there could actually be some moon particles lying around on our planet right now, just beneath our feet. Well, that's interesting. But which rocks? We have no idea. But they can use the rocks to find out how long the moon was formed. How long ago the moon was formed. So, next, as large planetesimals grow, heat was released by repeated impacts and the radioactive decay of elements inside their materials, enough to cause melting. This allows materials with different densities to separate, with metals like boron and nickel sinking to the inside to form a core and lighter rocks floating on top. So, I don't know how to explain this, guys. I'm sure most of you would know what this means. So, as you can see, we have Proto-Earth. Back then it looked very much like Venus. And of course Theia, about roughly the size of Mars, collided with each other and created a moon years later. So, yeah. So there are multiple different theories that are suggested by scientists. So Theory one, the moon broke away from the Earth. That's a fission theory. So they think that the piece of rock some scientists think the rock just came out from the Earth and just started floating away from us. But as I mean floating away, every year the moon moves further away at 4 centimeters. Just 4 centimeters every year, the moon moves further away from Earth per year. So, next theory, the moon formed elsewhere in the solar system and was captured by Earth's gravity. Oh, well, that's quite an interesting one. They think that the moon could maybe be an asteroid. If so, because moon is a rock, gigantic rock that we see in the sky. Could be an asteroid because asteroids are made of rocks too. So that's a capture theory. That's what some scientists think. And this theory three, the Earth and Moon form the protoplanetary disk at the same time. So they think that the Moon and the Earth might just form together without any collision, and that. But best theory, so far, is the one when the Moon crashed into the. Sorry, not the Moon. Theia, the other planetary-like object, has crashed into the Earth at the early stages, and happened roughly about 60 to 175 million years after the birth of the solar system, and it created a moon after that. So now we're going to talk about how did the Earth look like. So now this is the point where we get to when the water was forming and how the surfaces went solid from being a molten rock. So after the moon forming impact, Earth was a very different planet from the world we see today, where the present day Earth has oceans covering much of its surface. The early Earth was covered in a magma ocean, a layer of molten rock hundreds of miles deep that was melted by the energy released during the collision. Any water present would only exist as water vapor in the atmosphere. So there was no actual physical water on the surface. Only thing there was back then on our planet was just molten rocks laying around everywhere. Lava, as I would say. Lava and water back then was only in the atmosphere, vaporized as a humid. But there was no physical water on the surface. So over time, after the magma ocean cooled enough to form a solid surface, Earth's atmosphere was replenished by volcanic eruptions, as well as water and other gases delivered by comets and meteorites crashing into the surface. So comets and meteors, or asteroids, were the ones that actually brought water and gases to Earth. So, like oxygen or carbon dioxide, they actually all came from outer space and they've been brought to us, to Earth. So, all these things, the air that we breathe, the water that we're drinking, is actually, in fact, a gift from outer space, you guys. All comes from comets and asteroids. So next, How the life formed. Well, the origin of life on Earth stands as one of the great mysteries of science. Various answers have been proposed, all of which remain unverified. So, so nobody actually knows how the life formed millions of years ago on Earth. How did the very first life ever appeared on Earth? No one knows that yet, and we probably never will. Uh, well, that's the answer that we don't want to look forward to. The answer that we want is to know how the life was formed. So now we're going to talk about when did the life on Earth begin. So that's also another big question. When did it start? Earth is about 4.5 billion years old. 4.5 or 4.6 billion years old, but anyways, scientists think that by 4.3 billion years ago, Earth may have developed conditions that stay suitable to support life. The oldest known fossils, however, are only 3.7 billion years old. During that 600 million years after years window, life may have emerged repeatedly, only to be snuffed out by the catastrophic collisions with asteroids and comets. So, throughout the years, around the time when the first life was formed, they might have got extinct, and then they came back again. They've been extinct by the asteroids, and after that, the lives came back again as either plants or animals. So, now where did the life begin? So, two possibilities are in volcanically active hydrothermal environments on land and at sea. Some microorganisms thrive in a scalding, highly acidic hot springs environments like this found today in Iceland, Norway, and Yellowstone National Park. The same goes for deep sea hydrothermal vents. These chimney-like vents from where seawater comes into contact with magma, also known as lava, and the ocean floor, resulting in streams of superheated plumes. The microorganisms that live near such plumes have led some scientists to suggest them as the birthplaces of Earth's first life forms. Well, that kind of makes sense actually, because when water gets warm enough, not too hot, not too cold, it becomes perfect condition to form a life, basically. You know, like when you sit in a bathtub or something and you really enjoy it. It's a perfect type of temperature for a lot of other different types of lives, and this is possibility where the first life was formed. So what are the ingredients of life on Earth? What's the ingredient of plants or animals or us? What is the ingredients to make us? So the recipe consists of steady energy source, organic compounds, and water. Sunlight provides the energy source at the surface, which drives photosynthesis on the ocean floor. Geothermal energy supplies the chemical nutrients that organisms need to live. For us, these are carbon, hydrogen, oxygen, nitrogen, and phosphorus. But there are several scientific mysteries about how these elements wound up together on Earth. For example, scientists would not expect a planet that formed so close to the Sun to naturally incorporate carbon and nitrogen. So we're actually in a perfect place, our planet, to form a life. It's not too hot and not too cold. And so, of course, we need carbon, hydrogen, oxygen, nitrogen, and phosphorus to live on this planet. If you just take one of these away, we wouldn't be here. We wouldn't manage. So, like for example, on Mars, there are atmospheres there, but the only gases there are is carbon, but no oxygen and no nitrogen and no phosphorus because the atmosphere is just too thin there. So only carbon, and just that is not possible to live on. So now we're going to talk about the next video. So next video, we're going to talk about Mars. Well, not this Mars, guys. This is a chocolate bar that we all eat. But this is one of my favourite chocolates, by the way, Mars. But this is not the Mars we're going to talk about in the next video. We're going to talk about this Mars, the planet right after us, the fourth planet in the solar system. We're going to talk about how the Mars formed and how it maybe had life, but we don't know. But we're going to talk a lot more about this planet in the next video. So now, guys, so I want to say thank you so much for watching. You're probably wondering if I'm feeling a little bit better today. I am, but my nose is still running, but not as much as yesterday. But I'm sorry I couldn't upload a video yesterday because I was really ill yesterday and I couldn't do anything at all. But today I feel a lot better. Pretty much gone, almost, my sickness. So, and also I want to talk to you guys about why I don't make good explanations to things. One, I have autism. When I was about 4 or 5 years old, I was diagnosed with a very severe autism. I was about 80% autistic. I couldn't talk whatsoever. But throughout the years, I've been trying to talk, and I managed. I succeeded a bit. I can talk now, as you can tell. But when I was little, when I was in a primary school and that, before I was moved to the special school for children in need, I couldn't talk much whatsoever. So 80% autism I had. 80. That's quite a lot. Hard to believe, actually. So guys, this is it. Thank you so much for watching. Hope you all have a wonderful evening tonight. We have a lot more videos coming up soon in this planet series. Mars is next. And yeah, so hit the like button, subscribe, turn the notifications on, comment below, and that's it. So thank you so much for watching and have a great evening. Take care now. Cheerio.